Welcome to our session today. We will be discussing experimental research methods. So obviously this is within quantitative research, and let me give you some context. There you can see my full screen, or do you see something else in the
Yeah, I see a split screen.
a split screen? Okay. So let me see if I can share it in a different way. It's still split?
No, it's a full screen now.
Okay, so let's try it like this. So I was telling you to discuss experimental research methods. I want to give you some context. And here we have the research methodologies that we discussed already in one of our previous sessions when I was explaining what was a paradigm, an approach, and the methodologies and the methods. So within the quantitative approach, we have several research methodologies. And there I show you that we have the experimental method, the quasi-experimental design, the pre-experimental, the non-experimental, the correlation, that includes the correlational, the descriptive. We also have meta-analysis and structural equation modeling. So these are these are some examples of the designs that we have within a quantitative approach. And today we will discuss experimental methods. So we will be here. Let me see if I can, use the pen. So we will be here. We will discuss about experimental, quasi-experimental, pre-experimental. In our next session, we will be here, non-experimental and correlational methods. So this is just for you to know where we are, still within quantitative approach. Just at the end, we will briefly discuss qualitative approach, okay? Okay, so experiments in psychology. Here on the screen, you have some images relating to really famous experiments in psychology. I don't know if you can recall them. We have the Bobo doll experiment from Bandura. And we have the very famous Zimbardo prison experiment here. We also have here the ASH conformity study, for example, and we have the marshmallow test from Michel also here. I don't know if you are aware of these experiments, if you have seen them before. They're really, really famous, especially within social psychology. But I wanted to start today telling you that experiments, it's about control. It's about the manipulation of the variables in order to be able to establish causality. So the experimental design is the more strict one that we have in psychological science, and is considered to be the only one with which we can actually establish cause and effect relationship between variables. So this is the big guns in psychological science, the experimental research strategy. In order to accomplish this goal, an experiment must manipulate one of the two variables and isolate the two variables in order to not have any other variables influencing the experiment. So all the variables that are not the independent and the dependent variable should be controlled for. This is what control is standing for. So this is why most of these experiments are done in specific settings. As you can see here, for example, There is no colors on the walls. There is no toys here. Like it's an empty space. You only have a chair and a table, you know. You can only see one person, the experimenter. Usually, in order to control for these variables, we often use the same experimenter in all the subjects. So someone different talking to you doesn't make an influence, right, in the results. So we want to be careful where we are testing people, where is it, at what time of the day, who is testing them. So you have to be careful with everything that may influence the results of the experiment. So this is why all of these experiments are done in controlled settings. See, as you can see here, also very sterile. There is no many things. And also here, there are few things. And if you have something in the experiment, should be there for all the subjects. So in this case, just having it there, and because if you have different settings, this will influence or can influence. So if you have something specific, should be there for all the subjects as well. So you have to be really careful with all these things. And we will discuss today why it is important to have these elements in experimental research. So it is all about manipulation and control of the variables. In experimental design, the researcher must actively manipulate the independent variable rather than simply waiting for the variable to change by itself. With this manipulation, we can actually determine the relationship, the direction of the relationship between the two variables. Because if I am changing one of the variables now I can expect the change in the dependent variable. So you know when it should happen. This is why you should control it. When you put it in the environment and when you take it away, and it should have an effect that you have see reflected systematically in the dependent variable. This is why it's really important to manipulate the variable. Also, manipulating the variables will help you control the influence from other variables. Because if you are looking that the influence you are having is not systematic, maybe some other confounding variables, the ones that are responsible for the change you are observing. So this is why you need to manipulate it. You need the control over the independent variable. And this is why we want these special rooms or these special settings and have a really clearly defined variable and to manipulate it. So control also has to do with identifying any third variable that changes systematically along with the independent variable. Because this is a potential, obviously, potentially it may be having an influence in the dependent variable. So in this case, we have two kinds of this kind of stir variables, as we already discussed in a different session. So we have the co-foundings and we have the extraneous variables. So extraneous variables it is called extraneous because it's just different to the independent and the dependent variable. But an extraneous variable, which is a third variable, can become a confounding, and there is when we should be worried. Becoming a confounding variable is when the variation between the variables is systematically. So if it's happening systematically, then you know that because it's varying in the same way that your independent variable, then it's a risk. So it is more than just an extraneous variables because it's varying in this way. Now it could be a confounding. And if you believe if you have a confounding variable, you should control for it. How you control for it? Well, you have to measure it. And then when you are running the stats, let's say you are running a regression analysis, you have to put it inside And then all the variance explained for one of the variables will be hold constant. And then you have the output without this and with this. So in this is the way we can control for these confounding variables. So there are actually 3 ways in designing the experiment on how you can control for these third variables. And one of them is by holding all the variables constant. Is, as I told you before, for example, all individuals in the experiment should be observed in the same room, at the same time of the day, or by the same researcher. So in this case, you know you are not introducing these variables. Another kind we have is by matching values across the treatment. That is that, for example, age or socioeconomical status is balanced across treatments and therefore cannot be a confounding variable. So you are accounting for these elements to vary within your design, and because you are testing them and you are considering them a risk, and then you can control for them statistically. So you have to be careful with your samples. You have to match all the values across the treatment. So in another way, the simplest way to control for these third variables is obviously randomization. When you use randomization, any person can be part of the treatment group or the control group. So the assumption is that if you have someone that is influenced by a third variable, but you are assessing people randomly, you will have in both groups more or less the same kind of people. So if you're introducing this error, you're introducing this error the same in both groups. So this is the logic behind randomization. The best way to proceed is to account for as many ways of control that you can in your experiment. This is the best way to run an experiment. So as you can see here, already mentioned, another really important aspect is having control groups. Having a control group helps you reduce the influence of confounding variables and provides a basis for making meaningful comparisons, because now your results are, you have the way to compare if this group of participants are giving you these results because of your variable that you were manipulating, or because of another variable that you didn't account for. So if you have a different group that didn't receive the treatment but have the same results, then you know something is wrong, right? Because you didn't manipulate anything and the other group is exactly the same. So you know something went wrong there. This is why having control groups, it's really important. Generally, we have 2 groups: the experimental group, which means those participants receive the treatment condition in the experiment. So they were the ones, let's say, for example, let's say an experiment tasting if having coffee in the morning will help you to better do some of your tasks during the day. So if you want to test people with coffee and people without coffee and check their productivity, so the treatment condition will be people that had coffee for breakfast, and the control group will be the no treatment condition, so no coffee. So these are just 2 concepts that you must know: experimental group and control group. Having control groups is great. Every time if you want to conduct an experiment, I will advise you to have a control group. Obviously it's more expensive because you need way more people, but this is a more scientific way to actually test your hypothesis. So another important thing in experimental design is manipulation checks. So you are manipulating the variable, right? Let's say one experiment is looking into anger, and then they want to see how how someone that is angry will behave in a specific condition, and then they are inducing anger in the first stage, then to test that participant in the condition where they want to see their behavior. So imagine you are inducing anger, and then you are testing, then you are running your stats and making a conclusion. But if you don't know if anger was really introduced, then you don't know if your results are actually valid. Like, it is sadly a lot of research, for example, in psychology regarding stress. They realize inducing stress is harder than it looks. So we have a lot of stress tasks, inducing stress to people, like having to compute a lot of numbers, or running a lot of maths, or having a lot of stimuli at the same time, or noises, and we believe we are stressing someone. And then when we perform a manipulation check, like seeing if they are stressed or not, and then we are finding out that sometimes it doesn't work. So you need manipulation checks in your experiment. You can have it as an explicit measure of the independent variable. This is a scale that you can apply. For example, if you're inducing mood, then you can apply a self-report scale and see if they are experiencing, let's say, anger. Or another kind of manipulation is asking specific questions regarding the manipulation. You can ask the subjects if they were angry, or if they were feeling abused, for example, if they were bored. What do you think? What was the purpose of the experiment? And then with this kind of open questions, you can see if they were actually manipulated. So manipulation checks are really important in experimental design. So it is about control, it is about manipulation. Don't forget about that. And obviously, it is also about validity. How do we know if our experiments will yield valid results? So in experimental settings, we have two kinds of validity. Internal validity indicates how strongly you can demonstrate causation, how well you isolated the independent variable, the dependent variable, and you are measuring all the confoundings, the possible confounding variables, how good you did, how much you are controlling for the environment. So the more you control for the environment, the more variables you control, then you will have a stronger internal validity. So as you can see here, we can have an increase of internal validity with control groups, with random assignment, and with control of confounding variables. So the opposite part of this is having external validity. So external validity indicates how confidently you can be to generalize your findings to the broader population. So as you can see here, it's a trade-off between having internal and external validity, because if having internal validity is about controlling for everything, having a really sterile room, for example, not to have other variables like let's say light or noise or colors influencing your experiment. So you have a really plain, because you're controlling a lot, and this makes your experiment really artificial. So it is likely that the way you are behaving in this sterile room won't be the way you will behave in the real life, right? This is why having external validity is about being careful with representative samples. For example, having really an stratified sampling, for example, if you want to make an argument regarding, let's say, postdoc students in Germany, let's say like this. So you need to know how the population actually looks, like have the numbers, how many women, how many men, and different elements like socioeconomical status, age. And then how the population actually look, you should find subjects that are representative from that population in order to have external validity. And obviously, another way you can do it is by making the experimental condition resemble real life scenarios. So it's a trade-off, right? Because if you try to make a room more natural, let's say if you are testing the behavior of a child with his mom, and then you are setting up a kitchen, a normal kitchen. So having it be more real may influence the results, because some of the participants, they don't have a kitchen like that. And maybe the kitchen look really different. So maybe they will feel shy in this new kitchen. And you will have these differences. So it's a trade-off, really. And you have to be careful. Where do you want to go, and what do you consider is the most important thing regarding the construct that you want to assess? So now that we know what makes an experimental design, I would like to explain the different kinds of experimental designs that we have. And we can divide them by the methodological rigor, and we can divide it for the measures that they do of the participants. So regarding methodological rigor, we have experiments, quasi-experiments, and pre-experiments. So the more strict one is this one. This is the best one that we have in all psychological science. Is the only one. This is why it's called true experiment. It is all about manipulation, control, and randomization. Only with this kind of experimental design, we can actually establish cause and effect relationship. Most of the papers that we read, they don't have experimental design. They have a correlational design or a descriptive design, and all of these are non-experimental. We will discuss this our next session, but you must know the kind of experiments that will make the cut regarding establishing causality. Well, with less rigor, we have the quasi-experimental design. So this is exactly the same that an experimental design, particularly one that is called independent measure design, that I will describe next. So it is exactly the same that an experiment, but with one difference. The difference is that the independent variable is not manipulated by the researcher. See, so this kind of quasi-experimental designs, they have the rigor. They want to be an experiment, but they don't have the control of the independent variable. And sometimes this experiment exists because sometimes it's unethical to manipulate the independent variable. Let's say we want to do a study on divorced people, for example. We want to test how they evolve in the next 5 years, 10 years, like married people that stay married and people that get divorced. So you have two groups that you want to contrast. But obviously, you cannot manipulate it being divorced or married, because if you manipulate it, obviously, it's not ethic. It's like getting all people that is married and then making some of them get divorced in order to be an experiment. So obviously, you won't do that. It's not ethical. And this is why this will be a quasi-experiment, because the group is already there. So you will test people that is divorced and people that is married, and the groups already exist. So this is why you are not controlling for the variable. And this is why this kind of designs exist. And the less strict design, it has the less rigor, is the pre-experimental design. And it tries to be an experiment, but it doesn't get there. So sometimes these are good for explore the relationship of the variables, or maybe to create some hypothesis about them. Maybe you don't know how the relationship is, so you make a pilot study, or you are testing a small amount of participants, or you are not controlling for all the variables. So this is the kind of pre-experimental. This is why it's called pre-experimental. You conduct this and then you conduct the experiment. So it's just like trying to get the sense of how the things work in order to make it right now, then with the experiment later. So these three kinds exist, and we have other kind of experimental design, other division, and this is really important for you to know. You will continue hearing about this a lot, and this kind of division that has to do with the measurement that we do to the participants. This is not exclusive of experimental design. So these measurements between subjects and within subject designs are also present in non-experimental methods. So these are not exclusive of experimental methods, but one of them, because we have three match pairs design, this is exclusive of experimental method. So we will have this in this session, and these groups will also apply for our next session. So here, it's really easy. Having a between subject design only means that the participants are assigned only to one of the experimental conditions. So you have two groups, like the example that I was giving you with the coffee, right? So I have people that will drink coffee in the morning and people that will not have coffee in the morning. So we have two groups, and then we measure how they behave during the day, and then we compare, right? We compare between subjects. We compare between groups. This design, it is also called independent measures design. So because the measure, you only have one measure for each participant. This is why they are called independent method. So the opposite of this is having a within subject design. A within subject design just means that the participants, you will have two measures for each participants. You will compare results within the participants. This is why it is also called repeated measures. You will have two different measures, and this is a stronger design, because imagine in the example that I gave you regarding drinking coffee, some people can be better assimilating caffeine, right, than others. So for some people, just because of genetics, they they could work better if they have caffeine in their system. But this can be due to individual differences. Maybe some people is better with caffeine and other people is not better, right? So in order to control for individual differences, you need to apply a design like within subject, because you will measure these people one day having caffeine and the other day without caffeine, and you will test them the same people. So then you will know, like, if Ryan is behaving this way when he has coffee, and how is Ryan behaving another day when he doesn't have coffee. So then you will know more about this phenomena. So this is a stronger design. So as you can see here, I put you some advantages and disadvantages of both. And it is pretty obvious, but actually the advantages of the between subjects of having comparison of two groups is actually the same that the disadvantages of having a within subject design. So in this case, for example, having two groups and just measure participants once will reduce other effects, like fatigue, for example. If you are or also less demand characteristics, and also less participant learning, because you are not testing the subjects several times. So they don't learn your instrument, or they don't learn how what are you expecting from them? Because sometimes we have a phenomenon in psychology where we have this bias. We already discussed about it. When the participants know what the experiment it is about, or what the experimenter wants, and they learn these demand characteristics, and then they behave in a specific way. So if you are testing only one time the subjects, you don't have an issue with this. So this is why this is great. Obviously, it is the opposite case if you are testing them twice or 3 times or 4 times. So obviously fatigue, obviously they can learn the experiment, and obviously order effects in the order you are testing them, and they can reply differently. So as you can see here, it's also a bit of a trade-off. And regarding the disadvantages, for example, for having just independent measures, just comparing different groups, so you cannot control for individual differences, and then you need larger samples, because the other one within subject designs have more statistical power, because you have several measures of the same subjects. So you can say more things about it. And then the between subjects design can be resource intensive, right? And is obviously this disadvantage is obviously an advantage for the other group, which is more efficient, right? The way you use your resources. So we have these experimental designs. You need to determine if your experiment will be, you will have 2 different groups and you will compare the results, or if you will have one group and then you will test them several times. This is the 2 designs. And we have this tier 1, which is match pair design. That is actually each member of one group is directly paired or matched with a member of the other group based on specific characteristics. So this is even more strict. This is even more difficult to pull out. In this case, you are controlling. This is a way of controlling for individual differences the best way you can. So in a match pair, if you have, let's say you have 2 groups, one control group and one the treatment, and then you say, okay, I want someone that is really good at sports, and they can run 2 hours each day. So if you're controlling for this, then you should have one of these participants in each group. So you are assigning one to the control and one to the treatment. And this is you will do the same for all the variables that you want to control for. So you are matching. You are matching both samples. This is obviously really difficult to find these people, and this is why it is not very used, but obviously it is great when you can do it. One of the best examples of this kind of match pair designs are with twins, because studies conducted with twins, obviously they share a lot of things, like obviously genetic material, and also the environment, how they like their parents, the way they were raised. So this is great having twins, because you can assign one to the control group and one to the treatment, and you can know better the relationship between your 2 variables. Okay, so just to be clear, the key elements that you need in order to design an experiment is, first, clearly establish your independent variable and your dependent variable. Then you need to ask yourself, how will you balance internal validity with external validity? You want to control for most of the confounding variables, but obviously you don't want to do it too artificial that you are not able to generalize your findings. The third step is to know how you will manipulate your independent variable. Which treatments would you have? How many groups? How are you going to do the manipulation? This is a really important part, and we will see an example today of this. And finally, you have to determine if you want to compare two groups, two different groups, or if you will have one group and you will assess this group in several times. So repeated measures or independent measure. You need to determine this. And all of this will, if you do this in a really strict way and accounting for as many possible co-founding variables as you can, if you are clear in your hypothesis, then you will have a good experiment. But I want to remind you something that I told you the very first time that I addressed to you. If you want to have a strong research methods, the most important thing is to have theory-based construct, that your constructs are strong, that you have valid and reliable measures. If your measures are not valid or reliable, even though you have a really strict experimental design, then your results won't be able to tell you anything about reality. Also very important to have a clear hypothesis. If you don't have a clear hypothesis from the beginning, you won't be able to make inferences or make conclusions regarding the relationship. And lastly, remember, if you were careful with your construct, if you are careful with the kind of measurements that you are taking, right? They are strongly based on your theories, and then you have a lot of evidence that you already review regarding the instruments, and you have clear hypotheses, and you get good results with one sample. The best practice in psychology is to have a second one, and then a third one. So replication, try to replicate your finding. You need various samples, various scenarios in order to be able to truly say that you have a phenomena that you can explain, okay? So the experimental method, you know now, it's all about control, manipulation, confounded variables, being able to establish causality is the strongest design we have in psychological sciences, and it has its advantages and disadvantages. As you can see here, like isolation of variables is great, and it is also our most efficient way to demonstrate causality. Is the only method that can actually go for demonstrating causality. And because of being so strict, can improve the replicability of your findings. So this is the positive things. And the negative things, sadly, are that sometimes these designs are very artificial. And then we have ethical constraints, like sometimes you need to manipulate one variable, like introducing anger, for example, or stress, and this is not ethical anymore. Obviously, you cannot stress someone or you cannot traumatize someone in order to later test how this trauma is actually making an influence on some other variables. So also, this design is incompatible with a lot of research questions, especially if we are looking into personality psychology. So assessing personality, measuring personality characteristics. So having to manipulate specific things in order to test for personality, as you can imagine, is specifically hard. So many times it doesn't apply. And they are resource intensive. Usually you need a bigger sample and a lot of money to conduct them, a lot of time, and they can be limited in scope because you cannot generalize because of the artificiality that you have during the experiment. So it has his advantages and disadvantages that I want you to know. But now that you already know what makes an experimental design so good, establishing causality, and what kind of elements can actually tell you a lot about the research question, now I would like to discuss with you an example. So we will discuss now the Stanford marshmallow test experiment. I don't know if any of you are aware of this experiment. Do you know this? It's really famous in psychology, one of the most famous we have.
Yes, I've heard of it.
Okay,
I
perfect.
have too, just not, I can't remember it in detail though.
Okay, it will be great if you already know about this, because I actually today, I want you to think about what was wrong in the first experiment that they conducted in the 60s. And because it's so famous, this was published in the 70s. The research actually happened in the 60s. And Walter Mischel was trying to assess self-control with this. And he designed this test of the marshmallow. So as you can see here, we have a small video about it. I will play it now so you can remember the experiment. Let's see the experiment and take a look at the experimenter. Take a look at everything in the room, the experimenter, the kid. Take a look at everything, because I will like you to think in which things can be actually making an influence in these results. So let's see if I will be able to click here. Click, I don't want this. Let me see. You don't hear the audio, right? Can you hear the audio?
No.
There's no
No,
volume
right?
on my end anyway.
Yeah, something is wrong here. Let me see if I can just search it on YouTube. Okay, I think now. Let's see. Let me share the screen and let's see if now we can. Where is it? Is it here? Okay.
Okay, sit in that chair. All right, here's the deal. Marshmallow for you. You can either wait, and I'll give you another one if you wait, or you can eat it now. When I come back, I'll give you another, so then you'll have two. But stay in here and stay in the chair till I come back, okay? All right. I'm gonna go do something, and then I'll come back.
It smells yummy. It smells really good.
All right, so it's up to you. You can have it now or you can wait. Okay? Stay in the chair, okay? Okay. All right, so I'm gonna leave and then I'll come back, okay? So you can either eat it right now or you can wait. Either way, okay? Okay. How'd you do? Did you do good? You did? You wanted to eat it, didn't you? Yeah. So did I tell you to give you another one? Okay, now you can have both. You need them.
Yeah, she didn't wait. Okay, so this is the marshmallow experiment, really, really famous in psychology, mainly because Michel in the 60s, he was trying to assess self-control. So the original experiment was about having the treat on site or not having the treat on site. So his hypothesis was that you have more control if you are unable to see it, right? And he has his results confirming this. As you can see in the test, some kids, they will try to cover their eyes, to look other way, because not having the stimuli right there will help you with self-control. So this was the original aim of the study in the 60s. But then it got really, really famous because let me share my screen once again so you.
All right, here's
Okay, now it's the PowerPoint. Now I have audio on both. Do you see a split screen?
Yes, it was split like at
It
the
was-
start.
Okay. I have many options to share my screen. I don't know which one is. Well, I will try directly with PowerPoint. So here,
Yes, can see the slides.
let me see if I will be able to. No. Yeah, something happened with the PowerPoint when I was, because I have the video embedded in the PowerPoint. And when I canceled the reproduction of that, something happened with PowerPoint, and now it's not allowing me to go to the next slide. Let me see if I can close it and then reopen it. So I think there. So I was telling you that the main finding that time was having the treat on site or not being able to see the treat. So this was the main finding. But the reason why this experiment got so famous was because many years after Michel completed this experiment, one of his postdoc students tried to replicate. He did a follow-up. He did a follow-up of the participants from that experiment. And they test the children once again. Obviously, they were grown-ups by then. And then they found something really, really interesting. And is that the kids that were able to resist having the marshmallows, actually in the future, they were doing better. They have better grades, better SATs. They have less inclination towards illegal substances, for example. They have better jobs. They have, so on average, they were doing great in life, having better relationships. So it was a fuss because they say, okay, so it is about self-control. Self-control is the key element in order to have success later in life. So this is why it became so famous. And then this was the 70s, the 60s, the 70s. And then he published his book in 2015, talking about the marshmallow test and telling about his results. But sadly, in 2008, people tried to replicate this experiment and they were unable to replicate it. So it didn't hold. The thing is that let's take a look at the experimental design. Here you can see in the screen, we have the original published in the 70s. So their results were the self-control was self-control accomplishing to hold out for a second marshmallow is the key for academic and personal success in the future. This was with the second experiment that they run. But the replication that they did in 2018, they did both. The first study with the marshmallows, and then they follow up with these same participants, and they found like the findings was actually half of the ones that Michel was found originally. And then when this second group was holding for socioeconomical status, when he balanced for this, so he was more careful in the design, matching values across treatment, then they realized that the half of the finding they have, they become zero. So it was actually socioeconomical background and home environment, the ones that were key for holding for a second marshmallows. So it wasn't about being self-control, having self-control. This is why it was so interesting, and I guess very painful for Michel after publishing his book in 2015. So now we know that the findings don't have to do with self-control, because the second team, Watts, Duncan, and Kwan, they were more careful. Mitchell was controlling for confounding by holding the variable constant. That is, all the individuals in his experiment were tested in the same room at the same time, instructed by the same researcher, but he failed to have a representative sample. In this case, he was really criticized because he used only a nursery school from Stanford. So most of the children were actually of a high socioeconomical status. So this is why his results doesn't really apply to a general population. So this group was careful enough to balance for all these things, and they find this element of socioeconomical as important, but they actually control for a lot of things. They control for gender, for race, for birth weight, for mother's age at child's birth, for mother level of education, for family income, for cognitive functioning of the participants, and for home environment characteristics. So they were actually really careful, and they found that the one that has to do with socioeconomical status was the one that was actually accounting for the variance. So in the second design, they were more careful, and they were actually able to find that it's not about self-control. But now I would like you to tell me where were the mistakes in this design? Like, were you able to see in the video how was the environment? Did you notice that they have few stimuli there? It was the same experimental. Did you notice something that you will change if you conducted this experiment?
Well, I thought, thank you very much for that. It was very clear all through your talk about about what makes a good experiment. I was thinking about variables, and in the example about coffee, it really came out to me that you could be testing for coffee, and actually caffeine is what produces the cause. And I thought that came out really nicely in this example, where it was actually socioeconomic background that determined self-control in an environment. What jumped out at me, I mean, it's unfair to judge an experiment by 2 minutes of video, playback. What jumped out to me was the age was different of the children, vastly different.
Yeah.
In one case, there were two kids discussing the benefits of whether to eat the marshmallow now or later. What has always troubled me with psychological stimuli is that marshmallow isn't the same for everyone. So which is why it's really good to have so many conditions, so many variables tested for, and to try and rule out confounding variables. Some people don't like sugar. And some people have maybe 1,000 marshmallows at home, so why should they care? But yeah, that was really good example. Thank you. But I can't think of any more that I would have done differently. Yeah.
Thank you, Buki. All of them, great observation. Also, the level of hunger. Imagine some of them, they just had lunch, so they are not hungry, and some others, they may be starving. So we don't know if they control for that. Also, as you already mentioned, if they like marshmallows or not. Also, if they are used to candy or not, to consume sugar or not. So many elements actually play a role. And one of the things that I noticed in the video is the way that the researcher was talking to them. She uses different wording, different ways of explaining, and this can actually make a difference too. When you have experimental design, you need to know you have 2 or 3 lines, and you only can say these lines, because if you change the way that you explain, it can make an impact. So this is another thing that you have to be careful about. As you can see here, it seems almost immense, the things that you need to control for. Obviously, we try to control for the most we can. As I already told you, in the replication team in 2018, they were controlling for, the IQ level of the mother, the age of the mother when the child was born, they were more careful. So there are stronger designs and weaker designs, and obviously you want to make yours the strongest that you can. Yeah, that was perfect. And now let's talk about the construct they were trying to assess and what is happening, because the question that I have in my mind is if socioeconomical status is actually accounting for the variance between having the marshmallows or waiting or not waiting, then I think it is not really truly about the socioeconomical status. So something happens. So there is an additional psychological mechanism happening to people with low socioeconomical status versus high that is actually giving us this result. So now we cannot attribute it to self-control, as Michelle was trying to do it. But what other thing can be happening that is also related to socioeconomical status that may explain these results? So this is a way where we can think forward, taking this experiment forward. So if we know now that some kids will wait, some other will have the treat, and we know people with low socioeconomical status will take the treat, they won't wait, and people with high socioeconomical status, they will wait for the treat. So what is happening there? What other psychological mechanism can actually explain the relationship between these variables? Because we are observing this phenomena. Some people is actually making an effort now to have a greater benefit later. So if you want to continue exploring this kind of research, the way to do it is thinking about different theoretical frameworks. You need to know about what other theories may explain this finding and relating self-control with socioeconomical status, because they vary systematically, right? They are confounded. So in this case, you can think about different theories, like, let's say, discounting theory from socioeconomical, you can speculate what is happening there. And in my case, if you allow me, in my case, I believe that it has a lot to do with trust. The kind of person that will wait for the second marshmallow is the kind of person that is able to trust better that they will have the benefit later, and not having a specific some distrust that they must have it right now because they don't know what will happen in the future. So in my case, I believe that a theory like learned helplessness can help us explain this phenomena. This theory, I don't know if you are familiarized with, is really simple. It says that people can lose their motivation and they believe they cannot change their circumstances even when opportunities for control exist. This happens to people that were enduring a lot of adversity over and over, and they were trying to change their condition, but even then they didn't make any change in reality. So they were trying and failing, and at some point they lost motivation. They don't want to succeed anymore. They don't want to try it anymore. They just don't trust that their behavior will actually influence reality. So this is about learned helplessness, and it can be reduced by altering thoughts of patterns and behavior in order to regain sense of control. So we already know, because we have a lot of studies showing that people from low socioeconomic backgrounds, they present way more learned helplessness than people from a high socioeconomic status. So we already know that people that is struggling with money, they are struggling with life in many ways. They have different environment. They are constantly struggling and having adversity coming at them, and they are losing their hope, right? People with less socioeconomic status. So in this case, we could, if we believe this may influence the trust that the children have of the researcher, may influence if they wait for the candy or not. If we believe this is a good hypothesis, then we can test it. And I have here on screen an alternative design of the marshmallow test. So for example, in this thing that I was thinking about, for example, in a first stage, we can try altering thought patterns and behavior in order to make the children regain sense of control, and in a second stage, applying the marshmallow test. So obviously in this design, all previous variables should be controlled for. So taking all that we learned from the first study and then from the replication study, controlling for everything, socioeconomic status, controlling for everything. But then I will have a special treatment in stage 1, because I want to alter these thought patterns these children have in order for them to regain control. So I'm specifically trying to test if completing 3 simple and small tasks in the same environment, and then immediately after each completion of the task, they receive a small candy. And then I believe that if this happens like consecutively, and then you are completing a small task, and then you're having your candy, and then the same experimenter is giving you a second task, and then he has given you a candy, and then you're completing a third task. So you are gaining sense of control, and you are gaining trust. So obviously we will have 2 groups: the treatment group, where they are having the task in the candy, and then the control group. And then sometime after testing with the marshmallow test. And my hypothesis is that participants under the treatment condition will be more likely to hold on for the reward in the marshmallow test. So even though we are already controlling for socioeconomic status, but we are controlling also for trust and maybe modifying learned helplessness in order for them to trust the researcher. And if we find in the second stage that these kids that were trained to have trust and they were trained that they have the control over the reward, they will behave differently. And then if we run this experiment, we will see if socioeconomic status still accounts for most of the variants, or if we are explaining more with our new construct. This could be a way, for example, to make different calls in this kind of experiment, and to having different theories and trying to explain this phenomena. Always keep in mind that elements like randomization, having control groups, always will help you to account for more extraneous variables. Okay? Okay, very well. So the takeaway concepts for today are having experiments. It's about control, it's about manipulation, it's about randomization in order to imply causality. And we have between subjects and within subjects designs. So this is the kind of things that we learned today. And I don't know, what do you think about modifying these experiments?
Thank you. Sorry to jump in again. I thought that was great, because I was thinking that you can keep on trying to falsify that particular that theory that is to do with socioeconomic status. And I thought your the way to bring to thinking about trust as being the actual cause was very interesting. The one thing I want to say, though, is that if you reward immediately 3 times, then an argument could be made that the children are holding on because now they're satisfied. So perhaps to split, to give bigger and bigger timelines between the reward and the next experiment, to be sure that you're not creating a confounding factor.
Exactly, Bucky. This is the way you should think about, and this is why it should be also a small candy, and it should be smaller than the marshmallow. So maybe a really small one, the one that are many colors. So exactly, you want to account for all these kind of things, and then wait the needed time in order for them not to be satiated. Exactly. All of these things, you have to take it into account in your design, Buki. I don't know, what do you think about this kind of experiments in psychology? Do you like them, or would you prefer the non-experimental kind, which have to do with self-report, maybe a bit more observational studies, less manipulation? What do you think about?
Yeah, well, it's beginning to grow on me, because like I said, I'm from natural sciences background, which is, this is how you experiment. But ruling out factors within behavior and experience always seemed impossible to me. But it's becoming clearer how psychologists try to overcome this problem. I think that my big takeaway today is, at which point do you admit that you have a cause? Because you can carry on, you can go beyond trust. And for example, I was thinking you could say that is the children's, because this is where my work comes in, is how they think about the future. So that's another causal factor. So at which point do you think, yes, this is the actual cause,
this is the one,
and I'll stop here, like you would easily get in physics? You would get to a point where you think this is the cause.
This kind of variable that you just introduced has to do with discounting theory, which I discount the gaining on the future, because it's different to think in the future than the gaining now. So the best way to do it, Buki, first of all, is for you to be knowledgeable enough to account for most of the variables that can be implied there, and then controlling for. You have to measure them. Somehow you have to have a measure of them, and then statistically you will hold for them. And then you will see the amount of variance that they will explain in the final data. Because when you are holding for the variance that is giving you, for example, presenting this discounting in the future in each one of the children, and then you are holding for that, and then you are left with the other variables. So you can account for, is it socioeconomical status? Was it trust? Which one of them are actually accounting for the most amount of variance? So this is where stats can help you. And obviously accounting for all of these confoundings, and very importantly, Buki, and I think you are always worried about it, and it's really good that you are measurement, how you are measuring actually that you are actually assessing this construct. So are these construct, are these measure valid? You know, are they valid really? Am I assessing this? Because otherwise, even though you're trying to account for all of this, if you're measuring improperly, then you will end up with nothing once again. So you have to be careful. One of our next sessions is about measurement. Actually, we also have a visit to a lab here in München. So I want you to look at this environment. They are sterile, really sterile, but they are supposed to be like that. Now you know why. And also in our next session, we are looking into validity, measurement. So I want you to know how psychological science actually measure constructs and how valid are they? Like, in which one can I trust? There is no one of them that is actually valid or almighty valid. But the best way you can approach this is having several measures of the same thing and then seeing if they are actually measuring the same construct. So you have to be really careful. Obviously, it's about resources. Like, there is an amount of time, there is an amount of money, there is an amount of participants. So you are trying to take into account most things, but obviously it's not possible. Like Michel, he had these issues now. Well, he's still famous, but now he's carrying this non-replication finding. But this psychology, it's like that. Okay, Catherine, we have a question. Go ahead.
Yeah, so thanks. I completely agree with Buki. I found that really illuminating and clear and helpful and very interesting. And unlike Buki, it kind of pushed me in the opposite direction. Well, not the opposite direction, because I was always a little suspicious of controlled experiments in human science. But this has kind of vindicated my suspicion because it's just one really good example of the way in which background assumptions from your culture or your privileged status or your gender or whatever it may be, that how easily they can creep into your experimental design. And you know, I just it makes me wonder how you can even begin to account for the things that you're not thinking of because you're not thinking of them. And for me, that's a good argument for diversifying research groups.
Exactly.
But even that, you're never going to cover
you're never
all of the
100%
bases.
secure. Yeah.
So one thing I was wondering is how one might complement the kind of experimental research in the marshmallow experiment with more qualitative things.
Exactly. This is key, Catherine. This is key. I'm really glad that you mentioned it. We already discussed this problem of replicability in psychology. And one of the ways that I want to show you here in the course is I want to show you what is done and what is not properly done and which way we could go in order to make it stronger. So you just make an excellent suggestion, and this is mixed designs. So you cannot just have quantitative methods. You need to follow up. Remember, in my slides, I have, if you already have the finding once, try it with different samples, try different cultures, try different populations, try the most things you can, but also doing follow-ups with qualitative studies. Maybe doing focus groups and talking to these people and asking them, why did you wait? You know, why did you have the marshmallow? Talking to them, maybe they will explain some things, and they will take us in the right direction. Many times, this is a big problem in conducting experiments in psychology. People is trying to devise everything in advance without being in contact with the people. So you don't know their context, you don't know their needs, you don't even know if they like candy or not, or if they have candy at home. And if you are so, like, being so separated from the participant is good in experimental design because you're not biasing. But at the same time, if you don't use mixed methods, then you will always be a bit on the black, right? You won't have the full picture. So definitely having mixed methods, including qualitative follow-ups, will help us. And also cross-sectional studies. If you are measuring the participants in 2010, and then if you can measure it in 2015, and then in 2020, and then in 2025, and then you have more information, because you never know the way it's behaving, the variables can tell you a lot. So accounting for many things, it will give you to save shore. But obviously, once again, is resource intensive, and sometimes we don't have as much time or money. So when you are designing one study in social sciences, just try to be accounting for all of these issues. For example, if you are doing just qualitative studies, then you don't try to generalize, right, your findings. So you don't have these issues. You are saying, I studied this in this group of 10 women that are going through this adverse event, and it just applies to them. And they, they let me know this, and they think this, and they are behaving like this. And then you have facts. It's descriptive research, but then because you're not doing the generalizations, then you're not doing the mistakes. So the mistake here, I believe, in social sciences is trying to be too much like the hard sciences and trying to generalize with human minds. It's not possible, like personality, like environment, many different backgrounds, many things are in play. So we have to be extremely careful, or trying to assess extremely simple construct. This happens in cognitive science. In cognitive science, when they are trying to assess memory, for example, this is really simple. It's a memory test. And it's so simple, and they are measuring in such a simple way that you are actually able to say something about this. But if you want to measure self-control or awareness, or it's immensely more difficult, obviously. So we have to be careful also with our concepts, with our constructs. Yeah, but I'm really happy that I'm really happy that you are catching all of these things and you are worried about it and thinking about it. This is what the cross training is about. Telling you about the things, what the things are important, and how you could go around, and what kind of things could be helpful for your research particularly. Yeah.
Well, thanks for the great explanation of that today.
Yeah, you're welcome. You're welcome. And I guess this could be all for today. Hello, Ruben. We see you there. At the beginning, we were just 3. Now we are 4. We hope you are doing fine. And next session, you have a session with Marcus. You will be discussing elements of or experiences regarding publication in psychological science. So you will use this same link, and see you all next Friday, and enjoy your weekend, guys and girls.